Hello everyone, welcome to Patch Channels. In this series we are going to be looking at concurrent data structures. We'll be following the book titled The Art of Multiprocessor Programming. In today's video, I would like us to implement a linked list. Now, a concurrent linked list is a bit complicated, and in this video we will start by implementing a simple single-threaded linked list, which some of you might be already aware and know how to implement, but I would like us to build on that and see what this book suggests as the different ways of implementing concurrent linked lists. And then in the future, we may, if we get a chance, we may also implement other data structures. So our linked list is going to be really simple. It has three functions: the add, remove, and contains. The add, as it is, just adds a new element to the list. Remove removes an element from the list, and contains checks if a given element is on the list. Now, this might not be the best linked list you can implement, but as you know, we are going to be just using this as a step-by-step understanding of multiprocessing and how to design concurrent data structures. Our list will have a few rules. One, it has to always be sorted. Two, other than being sorted, we cannot add elements twice. In other words, we cannot have duplicates. Therefore, in this case, for example, if we insert B, if A and C are already there, then B will be in the middle of A and C. B cannot be at the end. If we try to add B again, we should know that B is already in the list and then reject the second addition. We'll try to keep everything simple, and we'll be developing everything in Rust. Right. Let's move on to the development. Okay, so we'll try to create a new project called linked lists. We navigate to that project and let's check out everything. Okay, we have our main function, which we can now try to add a module. Let's call this a singly linked list. So add new module. Okay, so let us start by designing a node. To this node, we shall be having a key. Let's say keys are I32 to keep everything simple. And let's see that we have next, which will be of type link. And of course, now we have to define the type link. Let's keep this as an option, so we know either we have a next node or not. On top of that, Rust does not allow nested types, so we have to wrap this in a box because the next node will also be a node, so we need to wrap this in a box. Let's implement two functions for adding a node, for creating a node. So we should say we have function that adds a node which is empty. This shall return self. I shall have a key as given, and for this function next will be none. Let's also implement a function that creates a node with a next node. Take a key and next. Shall also return self. So self here will be key, and next. Okay, so that works for our node. Now let us implement our singly linked list. This can be public, as we would like it to be accessible from outside this module. And it shall have a head, which will be a node. So this can be either we have a head or we don't. So it will be a link. Now let us implement our functions as required. First, we'll create a function that enables us to create an empty singly linked list. And this shall just return self with the head being none to make our lives easier. Next, let's implement the add function. This shall take a mutable linked list and the key that we are trying to add. And it shall return Boolean. As we know, if we add an element successfully, we should return true. If we fail, that means the element we are trying to add already exists in the list and we can just reject it. So let's assume that by default we shall return true. Now let's create a holder to the current node. Since this is a list, we would like to traverse it, and we will be traversing starting with the head. Let's traverse the list using a while loop. And first and foremost, if the key is already on the list, we shall return false. Next, if the key is larger than the current node's key, we shall check if the current node has a next. If that is true, then we can just move on. So current node just becomes. Otherwise, that means we have to insert. Otherwise, we have to insert our node, append to the end of the list. So that means node.next is equal to sum box new node new key. And with this, we shall return true. Okay. Finally, if our key is less than the current node, that means it should have been inserted before. And here we are going to use a trick whereby we create a new node that takes the current node's key and the current node's next. So we just pretend that this node was already there and it was supposed to be behind. Then the current node's key shall become the key we are trying to add. And the current node's next shall become the new node. And that's it. We shall return true. And now we are left with one corner case. In the beginning, our list is empty. So this while loop will fail and we will land at this place. So we just need to create the head. Okay, and this should suffice. So let's test, make sure that everything runs fine. Okay, we have a few warnings, but it seems to build fine. Let's write a test for our add function. Okay, CFG test mode. Let's call this module tests. We shall use super SLL. Let's write a test function. Let's call this function test add. Now, in this function, we're going to test a few cases. One, we should be able to append to the end of the list. Two, we should be able to insert a node in between two nodes. In other words, insert in the middle of the list. And three, we should make sure that we can't add duplicates. So let's create a new list. This list is empty. So to test for appending, let's add odd elements. So if I is odd, let's say if I is odd, then we must be able to add it because it hasn't been seen. In other words, list.add I must be true. I in 0 to 100. For even numbers, since we already have odd numbers, even numbers will be inserted in the middle of the list. So this should help us to insert even numbers. So again, this should not fail because we don't have any even numbers yet. Okay. Next. Now we have all the odd and even numbers added, so we shouldn't be able to re-add them. In other words, now trying to re-add them should fail. Okay. Let's test. Okay, so as we can see, our add function is passed. In the next video, we'll look at adding the contains function, which will also help us to test whether our add function is actually maintaining order. Okay, thank you very much. If you like this video, please like and subscribe. See you in the next video.